Okay, good day everyone. I am Martin San Pascual and I'm here to discuss a topic about WSD beams or to solve a problem. Okay, so number one example, compute the bending stresses in the extreme fibers of the beam for a bending moment of 37 kilonewton meter. The normal weight concrete has an FC prime of 28 megapascal. Determine the cracking moment of the section. Okay, so proceed tayo. Okay, so dito sa figure, sabi meron daw tayong 2 na 25 mm diameter na bar and meron tayong given na effective depth na for 20 millimeters and height given na 500 millimeters and yung 80 mm natin na effective cover. Okay, so given din yung pala yung ano natin, base na 300 mm. Yan. So take note na yung lambda natin is 1.0 kasi according sa problem is it is a normal weight concrete. So if it is a lightweight concrete, ang lambda na gagamitin natin is 0.75. Yan. So yung YT natin is 250 mm. So ano ba yung YT? YT is the distance from centroidal axis to its extreme fibers in tension. So hanggang dito. So basically kalahati nung ating H na yan. Okay, so yung hinahanap sa ating problem is yung the cracking moment of the section. So in order to do that, first step na or first thing to do is hanap natin yung ating FR or yung ating modulus of rupture. So the formula for our FR is 0.62 lambda square root of FC prime. So this is from NSCP 2015. So this is the formula for that. So substitute lang natin, the value of our lambda is 1.0 and the value of our FC prime is 28 megapascal. Okay, so ang makukuha nating sagot sa ating FR is 3.281 megapascal. Okay, so next step is to find our moment of inertia. So the formula for our moment of inertia is BH3 over 12. So since this is a rectangular section, so the formula for our moment of inertia is just BH raised to 3 over 12. Okay, so once again, substitute the values. Meron na tayong B, which is 300 millimeters, and meron tayong height na 500 millimeters. So, ang makukuha nating sagot is 3,125 times 10 raised to 6. Okay, so next na hanapin natin is yung ating bending stress of the beam due to moment. Okay, so ang formula sa ating bending stress or F is yung ating moment na given kanina, which is 37 megapascal. So meron din tayong YT, which is yung from centroidal to extreme fiber na 250, and yung ating inertia nakakakulang times to 1000 raised to 2. So substituting the values, makukuha natin yung ating bending stress na 2.96 megapascal. Okay, so checking if crack or uncrack. If yung F natin is less than our FR or yung modulus of rupture, our section is not cracked. So since ang nakuha nating F is 2.96, it is less than dun sa ating FR na 3.281 megapascal. So it means that our F is less than the FR. So it means that our section is not cracked. So we can say na yung section natin is uncracked. Yan. So, makukuha na natin yung ating moment of yung ating cracking moment na ang formula natin dito is FR multiplied by moment of inertia over yung ating YT, and para maging kilonewton 2 meter is times natin siya sa 10 raised to negative 6. Okay, so substituting the values, we got the FR na 3.281 and yung moment of inertia na 3,125 times 10 raised to 6, and yung ating YT na 250 millimeters. So, ang ating cracking moment dito sa ating section is itong 41.01 kilonewton meter. Yan. Okay, so next problem tayo. Okay, so next problem tayo. Reinforced concrete rectangular beam to 80 mm in width has an effective depth of 520 millimeters. It is reinforced only at the bottom with 5 to 28 mm diameter bar. The compressive strength is 28 megapascal and our FC is 12.6 and meron tayong modular ratio na 9.0, and ang hinahanap is yung moment capacity of the beam. Okay, so ito yung tsura ng ating problem. So meron daw tayong base na 280 sa ating base, and meron tayong effective depth na 520. Yan. So, meron din daw tayong bars na 5 to 28 millimeters diameter. Yan. So, given din sa atin yung FC prime na 28 megapascal and yung ating FC is binigay na rin na 12.6. So, ang hinahanap natin dito is yung moment capacity of the beam. So, first thing to do is find or locate the X dun sa ating problem, no? So, in order to do that, here, ito yung formula natin, yung bx squared over 2 equals to n as multiplied by d minus x. Okay, so substituting the value, yung ating base is 280 over 2, tapos equals siya sa ating yung n, yung ating modular ratio na given din kanina, which is 9.0. So yung AS natin is 5 to 28 millimeters. So 5 multiplied by pi over 4 multiplied by 28 squared na diameter, and multiplies dun sa ating effective depth na 520 minus x. So, if solved, makukuha nating x dito is yung 236.7 mm. Okay, so next thing to do is find the moment of inertia. So, in order to find the moment of inertia dun sa ating section is, the formula for this is bx raised to 3 over 3 plus n multiplied by as multiplied by d minus x raised to 2. So, substituting the value, since meron na tayong mga value na ito, makukuha nating moment of our inertia is 3461627,374 millimeters squared. Okay. So, to determine yung ating moment capacity ng ating beam, we have the formula for this, FC equals to m multiplied by x over moment of inertia. Okay, so since meron na tayo nung ating x, meron na rin tayo nung ating I, and yung FC is given, makukuha na natin yung ating moment capacity ng ating beam, concrete beam na M. So just substitute the values, 12.6 para sa ating FC, and yung x is 236.7 and yung ating over moment of inertia. So, ang makukuha nating moment capacity of the beam is 184.27 kilonewton meter. Yan.